Here we go. We are live. Hello, everyone. Let me just get a few things set up here and ready to go. Yeah, we're here. We're back. We are live from my basement once again. This time we're on YouTube as well. So we're on Twitch and YouTube now. It's amazing. All right, so I'm just getting some things set up here before we get started. Let's see. Oh, do this. What do we want to start with? Yes, we want to start with probably this thing here. Okay. Cool. All right. So let me just do a little bit of a recap from last week. This is our third week. I can't believe here we are again already on the third week. It's amazing. And we've had quite a lot of viewers so far, so that's kind of fun. And over the past couple weeks, we've done quite a bit. We started off with a basic hello world Lambda function deployed onto AWS with the serverless application model. That was pretty fun. And then we switched gears to building a little bit more complicated of a setup. So we added API gateway, a public endpoint. And then last week, we started tinkering around with making our Lambda function do something interesting. So we started building this poem generator service. So you can see here on the screen, I've got in front of me the Lambda function makes a API call to a open access API at Cleveland Museum of Art and gets the data for an art object. So there's something like 65,000 different artworks in this collection, all available through this API. And so we download one of them. And we use that document to inspire a poem built by Amazon Bedrock using Anthropic Claude as the large language model. So we got that all basically working last time. And just before I was about to leave, we were going to deploy it to AWS, but I ran out of time. So I think we're going to pick up where we left off a bit and finish that up. So we're going to do that, get it up and running on AWS, make sure it works the way we want it to work. I'm going to spend a little bit of time talking about Go packages, how to structure your code, that kind of stuff, so that you can reuse your code, other people can use your code, that sort of stuff. So we're going to tinker around a little bit with how to organize our project, and it will, sort of evolve over time. But so far, we've just kept everything in a single function, basically. So we're going to start to break things out into smaller chunks. And then we're going to come back to this and talk a little bit about, where we might improve it. So one of the things that I can see right off the bat is that this might wind up being a little expensive. If we're generating a poem on every request, that might add up to a lot of money after a while. And it also takes a little time to do the generations. So our end client user experience might not be that great. So we're going to talk a little bit about where those bottlenecks are and what we can do to kind of alleviate some of that pain. And then if we still have time, at the end, we might do like a little intro to DynamoDB, which is a serverless database on Amazon or on AWS. So we'll see if we get to that. If not, we'll put that off to the following week. Next time we go live, we'll dig into DynamoDB. But I think we might get there. We'll see. So let me just talk a little bit about this project. And I want to show you, I went through this real quickly last time. Let me see if I can switch over to, there we go. So this is the Cleveland Museum of Art's collections database website. So they, like I said, they have something like 65,000 artworks in their collection. And you can browse through them on this site. It's pretty fun. There's all sorts of stuff to look at. So here's, some highlights on their homepage, or you can search at the top. So you can type in like, show me all the chairs or whatever. But if you look at each one of them, take a look at like this guy here, Sacrifice of Isaac. You'll notice that they each have this little ID number here, and it's not a ID. It's actually a string. They come in different shapes and sizes. This one happens to be 1937.577. In the museum world, I actually used to work in museums, which is why I know some stuff about this. But in the museum world, these are called accession numbers. And it's the way museums use, uh, it's a way that museums identify records in their collection. So in the open access API, so let's copy this one. Hang on. So in the open access API, which is here, this is the documentation page for it. You'll see down here where they describe how to use the API, not this one, to get a specific artwork, you can either put in that accession number. So here's another one, 1953.424, or you can put in an integer ID, and they each also have like an integer version. So last week we were just playing with the integer version. This week I want to make sure that we can look things up by this accession number, because that's a little bit easier to work with. And it makes more sense, I think, if you're on the collection site and you see an artwork you want, that's what's going to be presented to you. Anyway, we'll try some of that stuff out as well. Cool. So let me change screens here to our code editor. Let's see. All right. I'm going to present something different now. Here we go. All right. So we're back in VS Code once again. Yeah, that looks pretty good. And so this is our project. It hasn't changed at all since last we met. It's really simple. There is a single Lambda function that we're looking at right now. So it's called main.go. And there is a go mod file, and that manages all of our dependencies. And so you can see we've actually only got 3 real dependencies here. There's the Lambda for Go package, AWS Lambda Go. Then there is these two, the SDK for Go version 2, and we're importing 2 different services there. We're importing the config service, or the config package, and Bedrock runtime service so that we can communicate with Bedrock. All the stuff below here, these are all automatically brought into your file because they're sort of tangentially related dependencies for these 3. So you don't have to worry about typing all this stuff in. It'll import everything for you. And then finally, we have our template file. This is our SAM template. This is the thing that describes what we're deploying on AWS. So we've got our generate poem function. It's a serverless function. We've got that events description. So we're going to have a get event. And then we've got a logging group. And our API, our API gateway is described here and further on down. And so you can see they sort of connect with each other. The API gateway references has the GET request basically defined right here. And then up top here in the events section, we make reference to the API. So here's generate poems API. That's how they're basically wired together. And then you can kind of do that visually using Application Composer, which you can get to just by jumping in here in VS Code. And I'll make this a little bit bigger. And so you can see here we are with the same thing. We just have our Lambda function over here and our API gateway over here. This nice visual editor. All right, cool. So let's see. I want to start off by talking about finishing up this Lambda function. And so let's just kind of recap what it does and how it's sort of structured here. So if you take a look, there's an import section up at the top, which we talked about a bit just now. So here's our different dependencies. There's some core packages that are defined right here. Those are part of Go, kind of built-in packages. And then we have a couple structs that we defined last time. So this is how we send our data to Bedrock. So this is the structured data for the payload that we want to send to Bedrock. And then we have our function handler. So this is the part that Lambda interacts with. And we get this parameter called request, which is an API gateway proxy request. And then we return an API gateway proxy response and an error. So those two parameters there. And then just to kind of dig through our code here a little bit, there's basically like three main sections. There is this part here in the beginning where we send an API request to the Cleveland Museum of Art's API for the artwork that we want to get. And then we basically read it from the response into a variable here. And then we use that document to craft a prompt. That's the second section here, where we put that string, the whole document, into these tags here, document tags. And then we have the actual prompt here below it. So we add the document to this. And this is designed in the way that Anthropic's Claude kind of wants it to be. So it has this sort of human prefix here, then the document. And then we just say, write a short poem inspired by the artwork described by the document. And then we have to add this assistant part to the end of it, sort of to let it know that that's where it ends. And so that's the whole prompt engineering business of this here, very simple. And you can kind of get really crazy with how you design these prompts to kind of get what you're trying to produce. But when we tested it last week, it seemed like it worked pretty well. So we'll keep going with that. And this third section here at the bottom is all the code we had to write to send our prompt to Bedrock. So pretty much this whole piece here gets us ready. So we have we create a configuration. So that just sets up our credentials with AWS. We create a service for Bedrock so that we know that we want to send API requests to Bedrock. And then a few parameters that are sort of required. So we have these two parameters here, and then the model that we're using. A particular model we're using right now is Anthropic Claude version 2.1. And then we use that struct that we created at the top to put in a bunch of parameters for the different configurations that you can do on Bedrock. So you've got the different number of the max tokens you want to use as your response, temperature, top K, top P, and your stop sequence. So all this stuff is levers you can pull to kind of change the response that you get. Last week, we talked a bit about marshalling and unmarshalling data. So here we marshal all that data into a byte array, and then we send that byte array along with everything else to the invoke model function from the Bedrock SDK, Bedrock Runtime SDK, rather. And so then we get a response back. Hopefully, we get a response back from Bedrock. And then we have to unmarshal that response so that we can do things like print it out to our logs, and then eventually return it to API Gateway and to the client. Cool. So let's try it, make sure it still works. So let's do a SAM build. Whoops, that's wrong. SAM build, just to make sure we're working with the latest code. And then we can do a SAM local start API. This will create a local API on our system. So we're not actually deploying anything to AWS yet. We haven't done that yet. And so it'll give us this URL. And rather than going into the browser or another terminal, just open a browser with the simple browser feature. We'll put the URL in there. And then you can see at the bottom, it's going to start invoking our function. Uh, and right now it's probably sending our prompt up to Bedrock, so it's going to take a few minutes or a few seconds. And there it is. So in the browser, we can see our response. Here is a poem inspired by the artwork, and then a poem, Misty Waters Still and Deep. So nice. So that's that. So that's a way we can kind of continue to test things, and we can let's split this to the right. Did that work? Actually, let's just move this over. No. Okay. That's okay. We can come back to that. Anyway, so let's stop our API because there's one thing about this that we haven't really dealt with so far, and that is that at the very top we have a specific artwork basically hard coded into our function here. So every time we run this function, we're going to be grabbing the document for the same exact artwork, and that doesn't really make any sense. We actually want to be able to pass that artwork ID in as a parameter so that we can grab any artwork from the collection. And so there's a couple ways to do this. There's actually 3 ways I can think of to do this, depending on what kind of a request we're doing. And so we're doing a GET request with this particular setup. And so within the GET request realm, there's kind of 2 ways to do it. There is path parameters. So path parameters look like, so if this is your URL, o.1, path parameters would just be like, some path. So we could just put like art/1234. And so we can grab this 1, 2, 3, 4 off the path and use that to grab the artwork we want. And then the other way to do it is with query string parameters. So we add a little question mark and we give it a name like ID and then equals 1, 2, 3, 4, 5, 6, whatever. Something like that as an example. And oh, you know what? Let me just turn off Code Whisperer. Okay. So that is another way we can do it. And what's nice about this is we can have many, many parameters all in the same query string. So either way works. I think the query string parameters are a little bit easier to set up because we don't have to modify anything on our API gateway. If we wanted to use path-based parameters, we would have to go into our template here and add something to the path. We would have to add a named parameter. So it would look something like this, ID as part of the path. But let's just use query string parameters for now. We can always try this another time. So query string parameters, you don't really have to do anything. We just have to capture the ID. Let's call it ID. So let's comment this out. And what we're going to do is we're going to use this request parameter here. Request, and we are going to look for query string parameters. And let's see here, query string parameters, and then we have to tell it which query string parameter we want to grab. So let's call it ID. Okay, so that means that when we go to our URL and if we add a query string parameter called ID, it's going to capture that ID into this variable right here, which is currently a string. And instead of hard coding it here, let's just leave that there for the moment. Yeah, that should work. All right, so let's give it a try. So let's do a SAM build again. Okay, let's do SAM local start API. All right, and then I'm going to open up our browser again. Let's put HTTP. Let's just do it like that and see what happens. Oops, I did this wrong. Just a sec. There we go. Okay, so we're gonna I think we're going to get a error because we don't have an ID. So let's see what happens here. Maybe not. Okay, now let's see if it's going again. Okay, yeah, we got an error. Um, Validation exception. So something was wrong with what? Yeah, it must be valid JSON. So I think, and we get an internal server error. So that's expected. So let's put in our ID as a query string parameter. And let's use that same ID from before. See if this works. All right. Okay, it worked. Cool. So it grabbed this ID, and then it sent our uh, prompt to Bedrock and got back this poem. So let's try a different ID. Let me just grab this one that we were talking about before. Hang on one sec. As you'll notice that this ID looks a bit different. It's got a dot instead of an integer. So it's actually a string. So 1937.577. So let's try it with that. And so this artwork is called The Sacrifice of Isaac. It's the one we looked at a little bit ago. And let's see if it can generate a poem for this one. Something's happening. No response from invoke. Oh, so it timed out. Interesting. So we got to the 30-second timeout. Let's try it again. I think it's going to time out again. Let's see. No, it worked. Okay. So, but it took almost 23 seconds or almost 24 seconds. So it almost timed out. But we made it. And it came back. Here's the sacrifice of Isaac. So it figured out the artwork we were interested in, and it generated this poem. But it took some time to do it. So that's kind of a bummer, and we'll talk about that in a moment. But I think our code, for the most part, is working now, uh, which is nice. So now we can delete this. Whoops, we can delete this little bit here. And so let's just add a comment here so we remember grab ID from query string for an artwork ID or accession number, something like that, just to remind me what it is. Okay. I suppose we could probably do some like validation for this in the future, just to make sure it's a string or that it's, within the realm of a type of a string we're looking for. But yeah, it worked. It's awesome. Okay, so what we can do now is we can deploy it. We can deploy this to AWS. So why don't we try doing that? Since everything seems to work, let's do a SAM deploy guided. But actually, okay, before we do that, I want to do one more thing. So in our SAM template, so before we actually deploy this, in our SAM template, one thing we haven't really talked about is that at the end, you can do what are known as outputs. And so outputs are very handy because they tell you, or they allow you to print out basically uh, things like what the endpoint URL is, or handy information like that. So let me just grab some outputs here. I have one written down here. Okay. So we're going to try this. Let me tab it in one. Okay, so we're going to make a generate poems API output. This is just the endpoint URL for our API. We're putting in the generate poems API name here. So it's going to build this URL for us. It's going to put in our region that we're working in. And the rest of it is kind of the standard form for our API endpoint. So that will help us to know what our API is. All right, so SAM build. All right, so now let's do a SAM deploy. And we're going to do guided since we haven't deployed this yet. So let's give it a name. We're going to call this go generate poems. US East 1. Yes, I want to confirm changes. Yes, do that. No, don't do that. Yes, that's okay. Okay, so everything else is pretty much the defaults. So it's now it's going to roll up all of our code into an artifact that it's going to upload to an S3 bucket. It's going to build our artifact and everything and start to upload it. Oh, we had an error in our, I should say outputs, I think. Let's try that. There's another command line tool called SAM validate. Probably should have ran that first. Let's try that. Okay, so that says it's valid now. So let's try. I don't know if you have to build it again, but let's just build it anyways. So let's do our SAM deploy again. So this time you can see it's going to bring in some of the settings we already created because it's saved that into the SAM config file here. So we can just go through and accept all the same stuff again. Except this one should be yes. Okay. All right, let's see if that fixed it. Yes, looks like it's going to work. So take a look at what it's doing. It's going to set up a permissions for Lambda, a log group, a role, our actual function, and then the three pieces here below are for the API gateway. So the API gateway itself, a production stage, and a deployment resource. So that all looks good. Let's hit it. Okay, so it's creating all this stuff in the AWS console, or in AWS itself. We could go into the AWS console and take a look at it happening in CloudFormation, but there's no need to. And when you do this, you can kind of watch over here on the right what's happening. So if you get an error, you'll see it here on the right. But so far, so good. Looks like it's creating our resources properly. That looks cool. Okay. All right, and here's our output. So remember, we made that API gateway endpoint output. So here is our URL. So if I copy this and I go to our little mini browser and I paste that in, we can actually run our function. So we get that same error, and we can actually try it again with our query string parameter. So this is actually on AWS itself. So ID equals that. Let's see if that works. Let's just wait for a little bit. Now, the last one took like 23 seconds or so. Uh, so that's something to talk about because we got an internal server error again here. So it might time out again. Just copy this. It's hard to tell if it's loading or not when I'm in this VS Code browser. So I might switch out to Chrome here in a second. Yeah, looks like it's still taking a long time. And then it's timing out. Okay, that's fine. Uh, let's do one thing here. Hold on one second. Oops. Yeah, it's still timing out. All right, so let's talk about the architecture a little bit and why things are timing out and what we can do about it. So let me jump out of this. One second, and let's bring up my architecture diagram. Okay, so here we are. Here's our architecture. Let's talk a little bit about what's going on. So we're making our request to API Gateway. Lambda is making a request up to the Cleveland Museum of Art, and then it's making a request to Bedrock to generate that poem, and then we have to send it all back to the client. So there's a few bottlenecks in here to know about. Number one, or timeouts rather. So number one, Lambda itself has a maximum runtime of 15 minutes. So the longest you can run your Lambda for is 15 minutes. And in fact, in our configuration for Lambda, let's see, we've got a 30-second timeout. So even if we have a 30-second timeout built in here. We can change that number to up to 15 minutes, but it's set to 30 seconds because API Gateway has a maximum timeout of 30 seconds. And it makes sense if you think about it, right? So like if I make a request from a browser, we don't want to sit around for 15 minutes waiting for the response to come back. 30 seconds is sort of a nominal amount of time to wait, and it's actually super long. So we'd rather have our responses coming back, in under a second or so, if possible. So we have a couple issues to deal with in terms of the total amount of time it takes to do things. Uh, so kind of a performance problem. The other problem I noticed with this architecture, and I mentioned this earlier, is that it might wind up being kind of expensive, right? So every request we're doing is generating a new poem using Bedrock. And so every request to Bedrock has a cost associated with it. So there's the number of tokens that you're putting in, so that whole document and the prompt itself, and the number of tokens that it produces, the poem. Those each have a charge associated with them. So if we, have this set up so you can make request after request, it could wind up being a significant cost. There's also just the invocation of Lambda that has a cost too, but that might be nominal compared to Bedrock. So what can we do about this? There's a couple ideas I want to share around stuff, ways we can sort of deal with this issue. But first, let's take a look at the console and just make sure everything got deployed properly, and we can take a look at some other features here. So you should be able to see you can see my console. So if we jump over to Lambda, um, let's see, here's our generate poems function that we just deployed. And if I go to my generate poems function, one thing we can do is we can look at the logs, right? So let's go to monitor. I think I showed you last week, we can actually look at these logs from VS Code as well, which is really handy. Um, but for now, let's just take a look in here. So we're getting errors. Yeah, 2 errors, no successes. So if we look at our CloudWatch logs, switch over to here. Okay, here comes our CloudWatch logs for that generate poems function. We've got our log stream right here. And so we can see what's going on, right? So we can see errors happening. Oh, we got an access denied exception. When was this one from? Yeah, oh, that's interesting. Okay, so that's another issue we might have to deal with here in a minute. And then, is that the same one here? Let's see. Error from Bedrock. Okay, that makes more sense. Access denied. So when we actually tried to run it on AWS, we weren't able to. And there's a simple reason why. It's that we haven't given Lambda permissions to do that yet, right? So let me bring up how to do that real quick, just a second, because we did that. Let's see if I have that here. Okay. Actually, that's not where it is. Let's see. Just a minute. Just give me a minute to figure this out. So we have to um, add the permissions to our template to allow Lambda to talk to Bedrock. Okay, so what I'm going to do to make this simple, because it is simple, but let's just do it in here. So what we can do is take a look at the console. So let me just jump to the right tab here. So you should be able to see Lambda. So if we go to our configuration tab here, now we can do this in SAM, but just to make things simple, I'm going to do it right here in the console so we can make it work. So if we go to our permissions tab, we can see right now the only thing that Lambda is allowed to talk to is X-Ray and CloudWatch. So what we need to do is go and fix that. So if we go to here, to the role that we created. Okay, so now we should be able to see the role. You can see where we have this sort of basic execution role that only includes CloudWatch logs. We have to also have an X-ray, for tracing with X-ray. So what we need to do is add permission, and so we're going to attach policies, and we're going to look for Bedrock. This one here. And so now we've got all three. We've got CloudWatch, X-Ray, and Bedrock. So again, we would normally do this in SAM in our template. I'll set that up later on because I need to grab the right string for it. But for now, we'll just try it right here in the console. So what that means now, so if we go back to our Lambda function and just refresh this, now we should see that we have the Bedrock access available to Lambda. So let's try this again. Maybe that was our bottleneck. Let's come over here. It wasn't really a bottleneck. It was just a permissions error. So let's try running this again. Now, it did work when we were trying it out locally. And the reason for that is that when we run it locally, it was picking up our credentials off of our system rather than uh, the role that we created for Lambda. So that's a little bit of a gotcha. All right, so cool, it worked. So this one was severed head, nice. So we were able to put in a query string parameter, which I think you probably can't see in this view. No, you can't. Let me change this real quick so you can actually see the URL bar. So let's do this. We'll do Chrome. This one here. Okay, so now you can see the URL bar. So I've added ID equals 130707, and it's created this artwork, or sorry, this poem. All right, let's try a different one. So let's go back to Cleveland Museum of Art. Let's pick out something different. Um, I don't know. How about this? This one's pretty cool. This big painting. So let's grab that accession number. Hunting near Hartenfels Castle, 1540. Very cool. Okay, so let's go to our API and plug that one in. So you notice I'm plugging this one in as an accession number, not as a ID, which should still work, hopefully. All right. It's taking a while. Let's see if it's working. It timed out. Okay. Well, but this time I think it timed out for a good reason. So let's go take a look at our logs in CloudWatch. So let's go back to log groups. Here's our generate poems log group. You'll see we have a new stream now, um, a more recent one here. All right, so yeah, so we did have some, here's a poem inspired by the hunt. So it actually did create the poem, but just as it was about to send me back a response, it it timed out. So we almost made it. It was still generating this poem, and before it was able to send it back, we hit the 30 seconds and timed out. This is obviously not really going to work for us, right? So if we make requests, they could take up to 30 seconds to generate. Uh, this isn't great. So let's go back to our code editor and start talking about how we can fix this issue. Well, before we do that, okay, so there's one really simple fix we can do to our architecture here, and that is to use a different model. So if I go to Bedrock, I will explain why. Okay, so here's our Bedrock in the console. So if we go to Bedrock and we go to providers, you can see there's a whole bunch of different models to work with. And we're working with currently is called Anthropic Claude 2.1. And Anthropic Claude 2.1 is awesome. It can take a maximum of 200,000 tokens. So that means it can process really big documents, much bigger than what we're dealing with. But two things. So one, it seems to be a little slower compared to this other one here we have called Claude Instant. Claude Instant only has a maximum of 100,000 tokens, but two things, it's pretty fast compared to Claude 2.1 because it's sort of doing less, and it's much less expensive. So it's about a tenth of the cost of Claude 2.1. So what I'm going to do is I'm going to change our model so we're actually using Claude Instant 1.2 instead. So I'm just going to copy this identifier here, and I think we're going to get really similar results for a tenth of the cost, and hopefully for much faster within that 30 seconds. So let's go back to our code editor. Hang on one sec. All right, code, here it is. Okay, so what we're going to do is we're going to go back in here and we're going to change this model here so that rather than using Claude 2.1, we're going to use Claude Instant version 1. And let's give that a try locally, see if that helps at all. All right, so let's do SAM local start API. Let's just try this locally first. All right, there we go. Copy you. And let's open up a mini browser. And we'll put ID equals, and let's do that same one we were just doing a second ago. Let me just copy this. I know you can't see that. All right, so let's do show run commands, simple browser. ID equals this. Let's try that. See if we get it in there in time. So it's doing stuff. You can see it doing stuff below. Let's see if it comes up with a oh, look, it worked. Cool, okay. So it's quite a bit less amount of time. So it only took 7 seconds to complete that whole thing. Okay, so that's definitely one way to uh, increase our performance. We still get a pretty good poem. I'm pretty happy with that. But let's look at our architecture diagram. Hang on one second. I wish there was a way we could just switch screens back and forth very easily, but I don't know that there is. So let's just do this. All right, let's take a look at this architecture. Let's just talk about what's going on here. So we've got an API gateway that has a timeout of 30 seconds. We have our Lambda processing our function, processing our code. That can go up to 15 minutes, but it's choked down to 30 seconds to match with API gateway at the moment. And Bedrock, we just changed the model that we're using. And that's one of the really cool features of Bedrock is that, just with one string change to your code, you can switch to Claude Instant versus Claude 2.0 or 2.1. So now we're using Claude Instant, and that's much cheaper and also a bit faster for our particular use case. And I think if we were doing some much more complicated document processing, Claude 2.1 might be the way to go, but that's not what we're doing. We're just generating little poems. Okay, so it's taking about 7 seconds still to get a poem back. Okay, so in the background, while that's happening, I'm going to redeploy it. I know you can't see this, but that's okay. It's going to deploy in the background while we continue talking about this. So I want to talk a little bit about what we might do to make this a little bit more efficient of a system, something that is much faster, so less than 7 seconds even, and something that's also cost effective essentially. So I have a few ideas, and to me, there's kind of like two categories of ways we can deal with this issue. Let me just make sure I covered everything I wanted to cover here. Yeah, okay, good. We didn't, okay. We'll go back to that in a minute. Okay. You know what? I want to switch gears. All right, so sorry about that. I was going to get into here what we can do to start making this more of an efficient system, but I forgot because what I wanted to do when we started was to take a look at our code and start to think about restructuring it a bit, and that's going to help us when we get to this part. So sorry about that. I'm just going to switch back to code editor real quick. Before I do that, let me just, okay. Okay, let me switch back to the code editor. We'll come back to this in a little bit. Totally fine. All right, so let's do VS Code. All right. And as you can see, I redeployed what we have, but let's take a look at our code. Let's close this browser, close this template. Because one thing that we haven't really done so far is kind of think about the structure of our code. Everything is in this single handler function. So it's just a long script all the way to the end where we return our response to API gateway. There's our main function, which basically just kicks off that process. And then up at the top, we have a couple structs. Okay. So this is fine for doing something simple like this. And I suggest if you're just getting started, this is how you start things. But eventually, this is going to get unwieldy, and it's going to make it difficult to reuse any of this code. And so if we think about this, we can probably start thinking about, section name, putting this into different sections, um, for each step, basically, and creating functions to kind of deal with each of these steps individually uh, as separate functions. So, for example, we could make this whole thing right here a function where its only purpose is to call the Cleveland Museum of Art API. So let's do that. All right, so let's make a function. So we just go up here a little bit, right here. Let's make a function, and we're going to call it get artwork by ID. Oh, let's just call it get artwork. Super simple. Let's put in a ID parameter as a string, and we're going to return. What are we going to return? Let's see. I think we're going to return a byte array and an error. All right, so let's put in let's call it, we don't have to call it anything. We can just put in a byte array and an error. All right, so we made our get artwork function. We have a little, that's missing a return. That's okay. And so what we're going to do is we're just going to take this whole bit here. And we're going to cut it and paste it right in there. And it actually might work just like that, except for a couple things. We're not returning anything, and we're logging stuff. We're doing log fatals. So I'll talk about that in a moment. So first of all, we want to return our byte array. Okay, so we're going to do a return b and error. Actually, we're going to return b and nil. If we get through the whole thing and it works, we're just going to return nil for the error and our byte array b. Okay, but a couple things here. So these log fatals, that's fine. That'll work. It'll just do the same thing it used to do. But we could also, instead of logging a fatal, so a log fatal, like I mentioned last time, will do two things. It will print a log to the screen or to your logs, and then it will cause a panic and crash the program. So we can do that. I think that would work just fine in this scenario. But the kind of a better thing to do would probably be to just return the error back to our calling function. So before we do that, so let's just leave it as is for now. And then in here, in our main handler, now we need to call that function. So we're going to get back, let's call it art error. And we're going to say get artwork ID. So we're calling get artwork, and then it's going to be coming back as art, and we just have to change this to that. And so we can so there's not going to be any errors to handle because we've handled them all here. So I think a better thing to do is really to return the errors. It's a kind of a better structure because then whoever calls that function can decide what they want to do with those errors. All right, so instead of doing a log fatal, we're going to do a return, and we're going to return nil, and we're going to return basically the same thing, but we're going to do it like this. Oops, printf. And we're going to do basically the same exact thing here. We're going to do this. Oh, I'm sorry. We don't want to do that. We want to do error f. Okay. Okay, so we don't have to use this log fatal anymore. What we're going to do is return nil for the response, and then we're going to return this formatted error, basically. If that makes sense. So easier thing to do would be to just go like this. All right, and then let's do this third one. Let's see, no. Okay, and then where we called it right here, where now we should handle our error here. So it's just like normal, we're going to do if error not equal to nil. This time we're going to do a log fatal f, and we can say error getting artwork. Actually, we don't, since our errors are already formatted, we can just pass back log fatal, log fatal error. And that should give us the same result, basically. So it should just give us a log message based on which error it happened to be, but that's all encapsulated right in here. So we just squished that whole thing down into a function to simplify our code. This next piece, we can do the same thing. So we can do a little prompt engineering function. So let's make a function called, let's call it craft prompt, right? And what do we need? We need our document. Let's just call it doc, which is a string. And we're going to return a prompt, basically, which is also a string, and an error. But to be honest, we don't really need to return an error. Well, we can. Okay, that's fine. So this time we're going to copy this whole bit, paste that in here, and the doc will be, instead of art, doc. And instead of, we can do that just fine like that. So we can do a return prompt. And let's just do that for now. We don't need to worry about the error for now. We can add some error checking in later on if we want to, but I think this is basically just concatenating a bunch of strings together. What could go wrong, right? So now what we want to do is we want to say prompt equals craft prompt for passing it art. But, okay, art is not a string, sorry. Art is actually a byte array. Okay, there we go. That looks like it should work. And then we've got this, so let's just type craft prompt. Then we have this whole section here where we send everything to Bedrock. Okay, so let's do the same thing as a function still. So this time we're going to say function send to, so let's say send prompt to Bedrock. So we need the prompt. That might be it. And then what are we going to return? Let's see what we wind up with at the end. Well, it depends on how much of this we want to do, but I think what we want is this completion piece. So completion is a string. So we can do this whole entire thing as a single function. Why not? And just return a string. Or an error, because we do have some errors to handle. All right, so same deal. We can take this whole bit here. Let's just copy this whole thing, except for the actual response here. Let's do it up to here. And then we're just going to put it into our function here. And I'll talk a bit about why we're doing this here in a moment. Okay. So same thing. We need to return a string at the bottom. Return. Let's just do return out dot completion. Is that right? Oh yeah, and nil. Okay, and let's fix up our errors. So instead of these log fail f's, let's do what we did before. We're going to do return func dot error f. Oh, sorry, we have to do return nil, but that's actually, so that's interesting. So you can't return nil for a string. You have to return an empty string like that, since we're returning a string. A couple things. So what I'm doing here at the bottom is I'm returning the actual poem itself. I could choose to return this whole struct back to our calling function, but I think this is a little cleaner. I don't know. If we did this, we would be returning nil for those errors, but since we're returning just a string, we return an empty string here. All right, that's fine. So let's go and finish these up. So return empty string func.errorf. That looks good. Next one, here's another one. You know what? I'm going to use the magic of copy and paste to make this go a little quicker. That looks good. That looks good. Now we're done. All right, so then we're going to send prompt to Bedrock. And so we're going to do, let's, instead of calling it out, let's just call it poem equals send prompt to Bedrock, prompt. Now we have to have our error here, right? And then we need to handle our error. It's going to be the same as this one here. And then instead of printing out this completion thing, we're just going to print out our poem. And then same with here, we're going to send back to API Gateway our poem. Okay, so we just refactored this whole thing. So the handler, you can see it all on one page now. The handler is much more simple to read, so you can just see the sort of the steps. We can add a comment here. Get artwork from CMA. Craft prompt, send to Bedrock, log the poem, return the poem. So very straightforward, easy to read now. And all of our functionality is in 3 separate functions up above here. So a few like basic programming stuff. This is really nice because we can reuse these functions. So if I want to do the same thing 2 or 3 times in a loop, I can do that. If I want to use it in some other context, in some other part of my program, I can do that as well. But there's more you can do. So we can actually, instead of making it just functions right in here in the main program, we can separate this stuff out into packages. So let's talk about Go packages a little bit while we're here. So you can see at the top we have this package main, right? So that's our main program. And then we have all these imported packages. So I like to think of this sort of as like there's sort of like three levels to packages here. You've got core packages. These are packages that are um, part of Go. They're built in. Then you've got the next level is kind of like local packages. So you can make packages right within your own Go program. That's what we're going to do here in a minute. And then you can create separate packages. So you can create a package that lives completely as a separate repository. Uh, and that's nice if you want your package to be used by other people, other projects, that sort of stuff. So those are sort of the three, I would say, levels of packages. I always think of it as kind of like user, group, and world in a Linux land. So you have these sort of user packages. Those are private to your Go installation. You've got your group packages that's local to your project. And then you've got these world packages that are public to the world kind of thing. Whether they're public or not, that's sort of here and there. What's interesting about Go and the way package management works is that if you make a local package within your project right here, you can actually reference that package from another Go project just by using the different path identifiers here, like we've done here. So you can actually build a very sophisticated package in this very bespoke project, and then rather than like pushing it out into its own repository, you can just reference it as long as you have access to that repository. You can import it. So packages in Go are pretty nifty. If you want to make a package, all you do is create a folder and give it a name. So let's make one called Cleveland Art, and then you make a file in there called, let's make it cleveland.go, whatever you want to call it. You know what? Let's make it clevelandart.go, and then at the top of a package, you just give it a name, Cleveland Art, and so it just looks like any other Go program. So let's make this get artwork part of a package. So I'm just going to copy this for now, and so I'm going to put it in here. I'm going to hit save. It's going to automatically add some imports at the top for what I'm doing, but that's it. So now we have a package that's separate. It's its own thing. And back here um, in our Lambda function, we can reference it a little bit differently. So rather than saying get artwork, we could say Cleveland art.get artwork, right? And so now if we look at our imports at the top, we'll see here's our Go generate poem / Cleveland art is being imported. So we're importing from that new package we created. And so then we can actually delete this function because we don't need it anymore, I think. Let's see if that worked. Yes, okay. Cool, so now we have a separate package here called Cleveland Art, and that's nice because now we can start to make the Cleveland Art package do other things. We can add more functionality to it. It separates it out into its own folder and its own sort of space. But what's more is that uh, we can actually import this package from another project if we wanted to. So that's kind of how you can create packages in Go. Okay. All right, so moving on. So we've got our project, it's working now. Let's jump over to browser land here. Hold on one second. let's go back to our architecture diagram because we were talking about how we can make this system a little bit more performant. And so yeah, so in my mind, there's kind of like two different paths we could go down here. One path is that we can start to think about doing more like asynchronous requests. So right now we have a very synchronous system. That means we make a request, uh, the request goes through API gateway, invokes our Lambda function. Our Lambda function calls this API. Our Lambda function then calls Amazon Bedrock. Once it's done processing our poem, it sends it back to Lambda, which sends it back to API Gateway, which sends it back to the client. So it's a very synchronous series of events. They all happens in order. And this guy over here, the client, is just left waiting for uh, a response. So an asynchronous request works a little bit differently. An asynchronous request means you make the request, and then it immediately says, "Okay, I'm working on your request. I'll let you know, or come find out when it's ready for you." And so then this whole process can go off and run on its own, finish its work, and somehow this thing has to get updated when it's ready. There's a couple ways to do that, or actually a few ways to do that. So, and I guess the best analogy I can think of for this is calling somebody on the telephone. All right, so hear me out. So let's say I call you up on the telephone, and I say I want to, you make a request on the telephone. So let's say you're ordering a pizza. Okay, so I call the pizza place and I say I'd like a pizza. And what does the person at the other end of the phone do? They say, okay, we'll make your pizza, and then they hang up. Right, so they immediately hang up the phone, and then they go off and make that pizza. Once the pizza's done, they need to bring it to you, right? And so there's a couple ways to deal with that issue. We need to basically let this customer, the client, know when their pizza is ready. So you can either do what's called polling. Polling means that after some amount of time, I'm going to call you back and say, hey, is my pizza ready yet or not? And you're going to tell me, yes, it is, or no, it's not. And if it's not, I'm going to call back again in like another minute. And I'm going to keep doing that until you say, oh, it's ready. Come and get it. Right. So that's called polling. The other way to do it is with what's known as a callback. So I call you up, I say, I want a pizza. You say, okay, we're working on it. And then this time you give the pizza place a phone number uh, so that when the pizza's done, they're going to call you back and say, hey, pizza's done. Come and get it. All right. But both of those scenarios require me to come and get it, basically. The third scenario, which is a little bit more, even more confusing. The third scenario is I call you up, I say, hey, I want a pizza. And rather than hanging up on me and dealing with it when we're done making the pizza, we put the phone on the table. All right. So the connection is still open. I'm still connected to you on the phone. And then as soon as the pizza's ready, I'm just going to pick the phone up. We're still talking to each other. And I can tell you, hey, pizza's ready. Come and get it. Or here it is. And what's nice about that in the world um, of making a website or building a service like this is that you can start to send back partial information, right? So you can put that phone down on the table, but let's say I've got the dough ready. I can pick up the phone and say, oh, you know what? The dough's ready. That's nice. Or later on, like it's in the oven now. You can kind of continually give me status updates on the progress of my request until we're done, and then we can finally hang up. And that the way to do that is with what's known as a WebSocket. So that's another way to make an asynchronous request. So that would totally work here, right? We could set up some sort of asynchronous request setup. The problem with this is that we still are doing a request to Bedrock every single time. So regardless of if we do it synchronously or asynchronously, it's ultimately going to go through the same process and generate a new poem for every single request. So if we keep sending you the same ID number, we're going to keep generating the same poem. Now the poems will slightly differ because of the way large language models work, but they'll be very close, especially in this particular use case. So that seems kind of like a waste. We're going to wind up spending more money than we need to, more processing compute power than we need to. It's going to take longer, so on and so forth. So the other strategy that we can think about, completely different from doing an asynchronous request, is caching, right? So rather than generating a new poem every single time, we can generate a new poem the first time and save that poem somewhere. And so the next time someone requests that poem, it'll be ready for them immediately. So that's basically caching. There's lots of different flavors of caching. Uh, so one thing we could do, probably one of the simplest caches we could probably think about, is a content delivery network. So this is called CloudFront. So we could move this over like this, drop CloudFront in here. And then what we do is we make our request to CloudFront. CloudFront says, hey, Origin, that's the API gateway now, do you have this? Do I already have this? And then if I do, I'm just going to give it right back to you. If not, I'm going to go through this whole entire process, and then I'm going to store that copy on what's called an edge server. One major advantage to doing this is that those edge servers, the place where it's actually stored, are located all over the world. So wherever I am, wherever this client is in the world, it'll make that that cached copy on a location that's closest to them. So if another client makes that secondary request, not only is it already there, processed and ready to go, but it's in a location that's close geographically speaking. So this would totally work. It's very simple to do. We could just add a CloudFront distribution to our whole process here. The one thing I was thinking about that doesn't really work here in this case is that if I have multiple clients, so let's say I've got somebody in New York and I've got somebody in India, what's going to happen is that it's going to do two full requests. So it's going to say, hey, do I already have this in New York? No, I don't. Let me process it. And then anyone else that's in New York is going to get that geographically close copy from CloudFront. That's good. But what happens if somebody from India says, hey, can I have that same thing? So it's not in the India edge location. It's going to go through this whole process again. So it's going to create the request, it's going to process the poem, and it's going to stick it on an edge location closest to India. So now we could potentially have two different versions of the same poem if it comes out slightly different. But more importantly, we're doing multiple requests to get that. So another thing to do to help with this would be to add some other type of cache. So rather than a CloudFront distribution, or in conjunction with a CloudFront distribution, we could save that to disk, right? So there's a couple ways to do this. We could save each poem to S3, to Amazon Simple Storage Service, right? We could use EFS. EFS is a shared file system that Lambda can connect to. Or we could use a database, DynamoDB, which I mentioned before. DynamoDB is a completely serverless uh, database that we can leverage. And so either of these would work. It really depends on what kind of functionality we want. So DynamoDB would give us additional functionality in terms of like searching for things or sorting things, basically looking stuff up. It's also super simple to just create items in a table on DynamoDB. S3 would work too, but we won't have that same search capability, but it might be cheaper, it might be faster, it's hard to tell. Depends on the size of our data. EFS is another alternative. So it's similar, it would be similar to S3 in this scenario, but Yeah, can't really think of a reason why it wouldn't be good in this situation. Really depends on the size and volume of data and how many requests we're making, that kind of stuff. So all three of these scenarios would work. I think what we're going to do is DynamoDB, since it's fun to try out DynamoDB, and let's just wire this in so to explain how this is going to work. Oh, that worked. Okay, so now we're going to make our request to API Gateway. Still a synchronous request. We're not doing asynchronous requests here yet. We're going to make our request to API Gateway. Lambda is going to do its thing. It's going to say, call the Cleveland Museum of Art API. It's going to generate a poem with Bedrock, and then it's going to save it to DynamoDB. The difference here is that what we'll have to do is in our code is check for that first. So what we're going to do is we'll say check to see if a poem already exists for that particular ID. If it does, in this table, just send it right back. If it doesn't, go through this whole process all over again and save it to the table before we send it back. That way, it'll be there for the next caller. And so this architecture starts to get a little bit more sophisticated. Now we have basically a local cache of our poems, and that can grow over time. And then we have a global cache with our content delivery network with CloudFront. So that'll help with latency. So people who are really far away from wherever this lives will get their content faster. And there's a bunch of stuff we can do if we're worried about things getting stale. For example, we can delete each poem after a certain amount of time, so that we generate a new one every month or something like that for each artwork, because the artworks get updated with new information. Maybe it'll change. These are all kind of like edge cases, but we have quite a bit of functionality to play with now. So that's cool. That might work. So I think since we're almost done here, we'll wait till next time to build the rest of this here. So next week we can start playing with DynamoDB. We can introduce CloudFront. I'll get the right permissions set up in our Lambda function for Bedrock. But that's basically it. Before we go, so we still have a few more minutes to go here before I have to leave. I want to show you a little bit more functionality in Bedrock that you should know about. So let's go back to AWS console. And let's go over to Bedrock. Here we are. Okay, so if we go down to settings, Bedrock has a feature called invocation logging. So hang on here. Let's go back to CloudWatch. Let me share this real quick. So sorry, that's the wrong one. CloudWatch. So CloudWatch is awesome. It's where we can centralize logging of all kinds of stuff. We've already been logging invocations to our Lambda function. All right, so if we go here, we can see here's our generate poems log group for our Lambda function. And this lets us go into each log stream and see like what's going on in terms of how that Lambda function executed. That's nice. However, we might want to also log what's happening in Bedrock. So to do that, let's create a log group. Let's just call it Bedrock invocation logging. Logs, sure. We're going to set it to never expire, everything else default. Click create. All right, so now we have our Bedrock invocation logs log group. And then back in Bedrock, we can turn on invocation logging. We have a few options here. So we can decide what we want to log. Do we want to log text models, image-based models, or embedding models, or all three? So I'm just going to leave it all three. We can log to S3 only, or we can log to CloudWatch only, or both. And I'm just going to do CloudWatch logs only for now. And now we just have to put in our log group we just made, Bedrock invocation logs, I think it was. We're going to create a new role, so let's call it the same thing. Something like that. We're going to skip over the S3 stuff, and we're going to click Save Settings. Okay, and it worked. So now, every time, I'll just show you how it works. Every time we, let's use our Claude instant. Every time we send a prompt, what is Amazon Bedrock, and we get a response back, we should be able to go over to CloudWatch, and we should be able to start seeing our logs arriving. Now, it might take a little time. Oh, there it is. All right, so now we have a log stream called Bedrock Model Invocations, and here it is. So we've already got our first log. And these are really handy for working with Bedrock because it tells you everything. So you get the timestamp, of course, when you sent that prompt. You get some information about your account, so who sent the prompt, very handy to have. And then we get like what region it was sent to, which operation. So this was invoke model with response stream. So that's a streaming response thing. Which model we used. And then here's the prompt we sent. So here's what is Amazon Bedrock as the prompt. And then all the configuration settings are logged here as well. Finally, it tells you how many input tokens you use. So we used 15 input tokens for that prompt. And then here is all the chunks of our response. So they're sort of funny to look at here, but this is really nice because you can, they come back as individual chunks. So for each token, basically. So we scroll all the way down. And at the very bottom, there's the end of the generation. And so we can see some information. We see the number of input tokens that we used, the number of output tokens, so that was 94, the invocation latency, so how long it took, so 2 seconds about, and first byte latency, so how long it took to start to get some information. And then finally, the output token count again here for some reason, 94. And so this is really nice. We can use this for all sorts of stuff later once we start to build our service to be a little more sophisticated. Like we could return, we could create an endpoint that lets you get like how many tokens I've used this month or something like that. Just an idea. But that was just one more thing I wanted to share before we close up shop for the day. So that was super fun. What did we do? We did a whole bunch of stuff. As usual, we got our service up and running, so we can send artworks to this API. We switched to Claude Instant so that it's going a little faster and it's significantly less expensive for what we're doing. And then we also refactored our code quite a bit. So we split things out into functions and eventually into packages so that we can reuse our code in different ways. And then we talked a bit about how to make the system overall much more performant. Yeah, next time we'll build that bit of it. So thanks everyone. Thanks for joining. That was super fun, and I hope to see you next time.